we found x, and now we want to find y. And I've got to go back down here. This video has been broken up into two pieces. Okay, so x is equal to 4. Alright, so we know what x is. So we take x, we plug it in. So we're going to have y is equal to 16 over 4. And of course y is also equal to 4. So we got our two positive numbers, and it turns out the two positive numbers are 4. Now the question is, is that really a minimum? We didn't do a graph or a line chart and test if it's a minimum, but it's pretty simple to find that. Now actually what I'm going to do, let's say that you know how to set it up but you forgot the calculus. Okay, you forgot how to do calculus, and working out there in the real world, I found a lot of engineers would do things like this that actually forgot the calculus. So, but that's okay, right? What we're going to do is we're going to go ahead and I just want to graph this. Let's graph this. Let's take a look at the graph, and we can determine from there where our minimum is going to occur. So let's go ahead and do that. We're going to graph x plus 16 over x. Alright, so this is the graph, and of course this is the area right here that we're concerned with. Okay. And right, so these increments here, this is 4, 8, 12, and you can see 16. So as you can see here, 4, okay, is occurring right here on the x-axis, and of course that's what we said that our x was going to be, was 4. And when we go straight up, you can clearly see in the graph right here that this is going to be a minimum. But remember what this graph is. This was the sum, remember, of the two positive numbers. So you could see that their sum actually is, it looks like the sum is actually going to be 8. Right, 4, 8, 12, 16. Alright, so if we were to graph this, we would just look, okay, that looks like the minimum right there, and so we know what our x value is. X is 4. We would take it, plug it back into that secondary equation, right? So this was our secondary equation here to actually find what the y value is. So on all these optimization problems, what we're looking at is, looks like I scrolled a little bit too much. We want to have some constraints. I call these constraints the secondary equation, but we need to construct the primary equation, get it all in terms of one variable. At this point in Cal 1, that's what we want to do. Get it in terms of one variable, and that's usually solving for one of the variables over here and then plugging it in over here. And then once we do that, we just take the derivative, set it equal to 0, and solve for whatever that variable is that's in there. And that's basically what we're going to do with all of these optimization problems. So sometimes you're going to have to remember formulas to be able to construct this primary equation here, and you might need to even construct the secondary equations. And of course this particular one here only has one secondary equation. But that's basically it. So if you forgot your calculus, you can, as long as you can set these up and graph them, you can get a good approximation. All right. So I'm going to be working a ton of these things and some geometry problems, maybe some finance problems. I don't know, all kinds of problems. There'll be a bunch of them, probably about an hour's worth at least on here. So, all right.